Hi, everyone. I'm really honored and happy to be here with you all today. I would have so much preferred to have been there with you in person, but also glad I did not give you COVID. So know that I look forward to joining you in the future for meetings. I'm going to turn off my, well, actually, no, I think this will work fine. So this work all started basically because the Apple industry in Washington was very interested in trying to manage risk that they felt had been exposed from the caramel apple outbreak that most of us do link to the end product caramel apples. But actually, in this outbreak, there was in the traceback investigation, ultimately they determined that the contamination occurred in the apple packing house, which was at a facility in California. It was a relatively small facility, but the Washington industry being so large wanted to try and figure out where their risks were. At this point in time, they're not really doing any sort of listeria monitoring within their packing facilities. And unlike a lot of fresh produce that is packed out just during the season, apples are storage crops. So they actually are stored in either refrigerated or controlled atmosphere refrigerated storage for up to 12 months, so that we have apples that are pulled out essentially and packed out all throughout the season. That refrigerated storage also makes a really nice environment for listeria, right? As you have decay occurring and things along those lines. So from that outbreak investigation, essentially wooden bins, polishing brushes, and conveyor belts were all isolated as food contact surfaces that they pulled the outbreak strain from, that essentially was linked back to illnesses within that outbreak. And that was a relatively large outbreak from 2014. We also continued to have other events. We had one more, thank goodness, small, but still outbreak linked to caramel apples again. The ultimate root cause wasn't really elucidated, but again, just exposing apples once more, and especially caramel apples. And then we had a series of recalls from 2017 to 2020, either on fresh or fresh cut apples, really looking at, kind of now that that there's an issue, more of your buyers start to sample and things along those lines. So it tends to be what we see within the industry. As I said before, Washington is one of our biggest players within the United States. Now, compared to China, the U.S. is dwarf, but within the United States, we do supply. Washington supplied a good bit of the apple crop, and I would say, when I was at Washington State University, this group was also really, really interested in trying to engage with the researchers wherever they could to try and prevent problems, which I think is a really great thing. So often, especially in the produce world, they go by the adage of, if it's not broke, don't fix it. And the Washington group was definitely not going to take this as their adage. So what we tried to essentially build upon was looking at, what was the kind of improvement that they could potentially adopt within the environmental monitoring programs. When I had initial discussions with them, it became really clear that they weren't quite at that, along the continuum of food safety culture. They weren't quite at the space where they really wanted to go in and start testing in their own facilities, but yet they still wanted to understand the risk. Testing for themselves and managing that environmental monitoring program seemed really too big and onerous to them. So we worked up essentially trying to adopt, could we come in as a research, project and partner with several apple packing houses and try and determine, what we could do as far as trying to identify where maybe some listeria risk within their packing environment. We also had at the same time FDA guidance come out for control of listeria and ready-to-eat foods. Of course, this is for all food products, not just fresh produce. And it honestly doesn't fit fresh produce very well because it's very much written towards the slant of having a kill step and greater controls as we do with most of our processed food products. And of course, all of these packers they're very large. They're all under some GFSI scheme. So they were doing some sort of environmental monitoring. It just wasn't slanted towards Listeria. So we really looked at trying to develop a couple of projects I'll talk about today and share with you the outcomes. The first was really looking at the verification of cleaning and sanitation programs. And, they really had this idea that they wanted to never test for Listeria species. And we know from the, food microbiology world that really the best indicator for Listeria monocytogenes is going to be Listeria species. But I kind of had to meet them where they were, right? And so we threw in a slew of different rapid indicators, aerobic plate counts, Enterobacteriaceae, coliforms, Escherichia coli. Most of them were monitoring for E. coli as a reference point. And then we were also going to look for presence absence of Listeria species on food contact surfaces. We're also going to go in and look for, per the guidelines that the FDA developed in production, essentially at the first break period, where could we find Listeria species in production? So that's what we'll kind of share with you today. So here's our list of indicator organisms. Again, I think that most of you in the room are familiar with them, but essentially with aerobic plate count, really great indicator for sanitation, right? Because we can measure log reduction, right? And always have recovery on our food contact surfaces and really give us a good indicator there if our sanitation crews are performing well. As with most industries, the sanitation crew in the apple packing industry was usually third shift, and it was kind of a revolving door. So that was a nice check for them to have. Again, with Enterobacteriaceae, we're getting a little bit closer to some of our pretty broad group, but again, give us more indication as far as fecal contamination, things along those lines. Coliforms getting a little bit closer, and then E. coli. Most of them were getting coliform E. coli counts, like I said before. And then, of course, we added in Listeria species. With Listeria species, again, we were looking for the whole suite of sensu stricto group, shown here in the little yellow box. And then we were looking for them, again, with all of our other indicator organisms after they had performed a cleaning and a sanitizer application just prior to startup. And then we came back in for Listeria species specifically and looked at that first break period, could we find any hits with Listeria? So this project took a ton of work. You're going to see how much sampling we went in and did. The graduate student who did it is named Blanca and Ruiz Yashunga. And she deserves all the credit for leading this project. And she's actually joined me here at the University of Georgia, where she's my technician right now and potentially looking forward to getting her Ph.D. as well. So you'll probably see her around and in the future. So again, we're looking at these indicator organisms in our design of experiment. They also wanted to look at some rapid testing. Some people had not moved to doing E. coli coliform counts. Some were still relying upon ATP for environmental monitoring and assessing sanitation. We know that there's benefits to doing ATP monitoring. You do get a rapid result and can have corrective actions implemented immediately based upon thresholds you've established. We also throw in glucose and lactose swabs. Just because, why not? When we're throwing everything at this, in addition to our suite of indicator organisms, and then of course, presence absence for Listeria. We did do essentially an enrichment, followed by streaking for isolation on a MOX, and then just traditional PCR for amplified product. Our sampling sites were very diverse. They were all food contact surfaces. We were looking at essentially from the start of the unit operation, the washing and dump tank section. I have a flow diagram coming up when I'm talking about the next study. They'll help kind of orient you a little bit more if you've never seen a traditional produce packing line. They float in the apples from the bins into this dump tank. They go through a flume, and then they go through essentially a series of beds where they're washed and sanitized again. Wax is applied, and then they go through a tunnel dryer to essentially solidify that wax and dry them off. And then they go into sorting, where they have really high-speed sorters to look for internal and external defects. And then they're packed either in trays or in bags. Within each of these surfaces, essentially, we took several swabs that were adjacent to one another. So we had one swab that was all of our indicator organisms. We had another swab that was for ATP, another spot that was for ATP. The next adjoining spot was for glucose and lactose. And then we sampled a much larger surface area, essentially a foot by a foot, that was going to be for our Listeria species detection. All the other areas were 100 centimeters squared. You can see the methodology outlined here. I'd be happy to discuss this with you in more detail, and all of these results have been previously published. So getting into the results and really the heart of everything, what we saw within, looking at the indicator organisms, and again, this was just after they had performed a cleaning and sanitation event. Honestly, when it comes to aerobic plate count, we kind of saw what we expected. I would say nothing was too crazy once you got in and start looking at some of those surfaces. The different letters behind the counts, and all of these are again log transformed, are going to show you the populations that were recovered. They're relatively high for aerobic plate counts, but when you consider that within most of these facilities, they're not going through and conducting a cleaning and sanitation event for all food contact surfaces at one single time, and especially on the dry side, which is essentially from the sorting and packing on down, that is done on a less frequent basis. What we did see was essentially that wax coating and tunnel drying unit operation had slightly higher populations. That is not as surprising, considering that the wax is a unique soil that is essentially a lipid base, and it's harder to remove. And some people do better jobs at that than others. We were in 5 apple packing facilities, and we sampled over quarters for each of these results. So these are quite a few results pulled together. So for each of these unit operations, these are the some sites that we sampled for those quarters in those 5 facilities that fell in these different unit operations. We saw our lowest populations within the aerobic plate count, but they're just slightly lower, as you can see. So that, I thought, would give the industry a bit of a benchmarking, right, for looking for improvement if they're using aerobic plate count to try and further push the needle and drive those populations, lower them. For Enterobacteriaceae, we did see lower, as you would assume, we would see lower and lower populations. So we saw our highest populations actually in the washing sanitizing unit operations. That is on the front line, where hopefully we're getting rid of those microorganisms that they go throughout the pack out. Again, just slightly higher than what we saw as we moved and cleaned product and got down to our packing and sorting. For coliforms, and again, know that coliforms and E. coli are what most, if they're doing any sort of microbial monitoring, we're actually looking for in their environmental monitoring programs. We saw, again, them follow the same trends that we saw with our Enterobacteriaceae, with us having the highest populations in washing and along those brush beds, as well as the lowest populations in sorting and packing, which is a dry unit op. E. coli was really, really low populations. I kind of pushed them that, we don't see really high E. coli populations coming in on apples all throughout storage. Although it may be a nice indicator because you get good results, it may not be really helping them assess the true measure of how well their sanitation crews are working, or how well those approaches may be eventually getting everything nice and clean. We also wanted to look at correlations between these indicator organisms and our rapid tests, right? Because they were doing the rapid tests far more frequently. ATP is the standard bearer for them. And although we know from a lot of other industries that we don't tend to see correlations, occasionally we do. And they were especially interested in that. And I would say that this is one thing that as researchers, we have to be open to, right? Because there has to be something in it for everyone. And if it's something that's really interesting to the group that you're working with, then you need to make room for that within your experimental design. What we ultimately saw was that inevitably, none of our indicator organisms correlated to ATP counts. And we had really, really low R squared. So you couldn't be making inferences to, what the microbial population would be based upon ATP. Not to say that ATP is a bad tool, because again, it does give you really rapid results that you can have actionable reclean events and then go through and finish out your sanitation on. But it just wasn't going to buy you an indication of microbial populations, which is what they really thought they were getting out of it when you had conversations with different packing operations. We also, again, looked at the glucose lactose swabs. For those of you in the dairy industry, you know that this is more frequently used there. But again, we didn't really see very good correlation at all between a pass, and you don't get a number value here, you get a pass fail. The only thing where we saw a very slight significance was in the aerobic plate count. And that kind of makes sense, right? Because we had such high populations there, we may start to see a little bit of a shift within passing and failing for these rapid tests. But otherwise, we did not see any correlations. When we looked at the rapid tests themselves, as far as what was the average value that we got from different unit operations, inevitably what we did see was that the packing unit operation had the highest amongst everything for ATP and glucose lactose percent pass fail. Inevitably, I would say that this is what I would owe very much to less frequent sanitation events within these packing unit operations. And therefore, you're getting more soil load building up over time that you're picking up on in that ATP monitoring, right? And it's not as if they never clean and sanitize the dry, quote unquote, dry side of the line. It's really more so in the fact that they're doing it on maybe every 3 days to a weekly basis, whereas on the wet side, they're doing it every single day. The industry also liked the fact that this gave them a little bit of ground truthing as far as how their numbers stacked up to other numbers, because we all know that whenever we're dealing with, any sort of trying to set a benchmark, it's really nice for people to go in and establish their own baseline. But inevitably, it's also really helpful for, if they haven't gotten there, right, for us to give them a little bit of an indication as far as what we may be looking forwards in other industries. We did see that, again, all these values for the ATP is based upon log 10 transform units. So essentially take that into account. It wasn't 2.3. It was log transform, so we could get statistics run and everything. For our Listeria species within this kind of scenario, what we did look for was essentially, was anything correlated to Listeria species presence, absence? And again, no, we did not see anything that was significant as far as the samples that tested positive versus those that were negative. Again, we weren't sampling the same exact surface. It was an adjoining surface. So there is a limitation there. But again, we didn't really see anything that would give us really high correlation to say, yes, we're going to be able to test for coliforms and replace that with, instead of testing for Listeria species. The industry was, again, really, I would say, anxious about not ever testing for a listeria species. They didn't want to go there really. And I would say that that's just, it takes a little bit of socialization, right? And getting them used to things. We don't want people to jump into environmental monitoring and not be ready for doing a little bit more, have a proper response plan and developed and everything along those lines. So it's probably safe that they were not looking for listeria species, but at the same time, they were potentially opening themselves up to a little bit of risk based upon what we had been seeing. So again, what we found from this first study was the rapid tests aren't suitable for predicting microbial loads, but they're still a really good rapid feedback tool for sanitation programs. And then also Listeria monocytogenes and Listeria species harborage cannot be detected when utilizing indicator organisms other than Listeria species. I'm going to pause here. I see I have something in the chat. Oh yeah. Feel free to pipe in and let me know if you have any questions as we go along. I'm going to start into the next study though. So again, Blanca continued this project, and essentially we were doing this all concurrently. For the second piece I'll talk about, essentially what I just showed to you was the sampling we did in the 2018 crop season, coming in once a quarter and then just swabbing after sanitation event. We were also sticking around and swabbing at that first break. We did this over, again, 4 quarters, each of the 5 apple packing houses in Washington State. We had a big variety of packing houses. They're aligned based upon marketing desk. So we picked different packing houses from different marketing unit operations. That's typically where your food safety standards are set, because it's their brand that shows up on the boxes and things along those lines. But that's inevitably coming from multiple packing houses. So we tried to get a pretty good array of different management schemes and practices involved there. We came in also in 2019 and essentially executed on the same thing so we can have a larger sample size. And then I'm going to share with you today not only those post-sanitation results from 2018 that we just saw, but also look towards what we had as far as in-process positives, really trying to look at how feasible was it for the industry to utilize the FDA guidance document. This shows the flow diagram that I was mentioning earlier. Again, the apples come in on a dump tank. There's a sanitizer involved there, but this water is recirculated and do get organic load buildup over time. They exit onto brush rollers where they're rinsed with a soap and then washed through a series of sanitizers. Either chlorine or peroxyacetic acid are most common. They go through blowing fans, and then they go through the wax application, and then they go into a tunnel dryer. And then essentially, if you have a facility that's physically separated, this is the hole in the wall, and they come out on what's quote unquote the dry side. That isn't always the case. Sometimes they're packing just full open rooms, all with this together. And then they go through the sorter, and then they go through packing lines. This is the same scheme I just showed to you before, just kind of anchoring to when I say something's on the washing unit operation, what are the sorts of surfaces we saw there? Again, a lot of stainless steel. We tried to pick what was the most opportunistic from what we know from other studies. So really trying to look at joints and welds and things along those lines. Plastic flaps are everywhere in any produce packing operation. They get filthy and they're really incredibly hard to clean. Interlocking belts are kind of a nuisance for a lot of different processed food as well as packing facilities. We had a ton of brush rollers other than just our traditional brush rollers, a few shown here on washing lines. So we sampled those pretty regularly. And then of course they had a real love of using Teflon tape. It prevents scuffing essentially and bruising, but it also can lose its adhesion over time and then trap water inside. So we sampled that pretty significantly. Again, we're just focusing on Listeria, so we're going in with the same size and following exactly the same plan that I described to you before, looking at ultimately PCR confirmation. And we were just looking for Listeria species. We were not differentiating between monocytogenes and the other sensu stricto group. So what we're ultimately trying to find in this part of the study were what were our niche points for Listeria on food contact surfaces. What we saw was that we had an overall 4.6% prevalence across all of our, when we aggregated everything across these 2 years, and both sampling points. We had a much higher prevalence when we looked at in process as compared to our post sanitation, which is to be expected. Although apples do not have direct contact with soil, in the arid Northwest desert, which is where all the apples are grown in Washington State, there's fine bits of soil that are deposited on the apples as they come in. And so since they come in with that soil load, it's to be expected, you're going to find it. The unit operation that had the highest percent prevalence was the wax coating. This was a bit surprising, and really helped us get some messaging out about the wax entrapment, most likely, of Listeria, and essentially not getting that food contact surface clean, as a risk point for a lot of these packing facilities. The next two highest prevalence rates were the first, so underneath on kind of these brush rollers, but underneath fans, as well as in a tunnel dryer, were next to highest prevalence rates when we looked at the continuum. We also saw, I will also mention that, places where we're applying, it's not only design of surfaces, we have the same brush rollers being applied here in the washing, rinsing, and sanitizing as we do in the drying. The real difference is if you're continually applying a sanitizer. So in the washing and the flume, as well as in the these brush beds, we have sanitizer traditionally continually applied, and therefore getting lower hits inevitably. We also analyzed the data across quarters, and we saw that for our total prevalence, we did see it break down by quarter. Remember that apples are staying in storage towards Q4 the longest, potentially giving rise to greater Listeria prevalence during that cold storage time period. For some unit operations, they were always a sticking point. This is essentially the wax coating operation was continually aggregating and collecting Listeria species. For our breakdown of food contact surfaces, we really saw that the polishing brushes, again, that are in that wax unit operation had the highest frequency we looked at on a surface by surface basis. We then saw the stainless steel dividers under fans and blowers, which I have a picture of coming up next. They're essentially an example of an immovable surface that was hollow underneath and was not getting cleaned. And so trying to design that out so that you could remove that catch point was our messaging there. The dryer rollers was another catch point. Again, it's just fouling with wax. The brushes under the fans and blowers, again, was just a really hard hygienic design problem, right? We're probably not going to get away from them, but just the messaging that your sanitation crews needed to have more time and effort dedicated to cleaning and sanitizing those, and less effort maybe could be focused on some of the other areas that were not really associated. And then bristle rollers are essentially the rollers that come farther down in the stream that tend to be longer in length, and were cleaned less frequently. And they were on the exits, for example, from the wax unit operation. Everything else, kind of shown in this table was what I called middle ground. It didn't mean they were great. You can see the frequency of isolation there, and the number of samples that were collected, but they weren't our biggest risk points when we divided the line in the sand, essentially between 5% and our next up being 8% for the bristle rollers. We also had some food contact surfaces that were really less frequently isolated. Listeria species was less frequently isolated, such as the brushes under the spray bars, the stainless steel dump tank and flume, even though we had some pretty gnarly welds occasionally and things along those lines. And it's most likely due to that infrequent or that frequent sanitizer application. PVC rollers have traditionally been, due to their hollow form, have been a catch point. We did not really see any risk in this study based upon how they're maintaining those PVC rollers. And I think that had been a focus of theirs in years past, and trying to remove and do preventive maintenance so that they weren't a risk. Things along the dry side, the packing tables, the cup droppers, and the sorting brushes were not ever isolated. No Listeria were isolated from these surfaces. We also looked at breaking down by timing of sampling. When did our specific surfaces really, were they positive to begin with and they stayed positive, or were they negative to begin with and then were positive, or were they positive under both sampling time periods? And what we saw was that essentially the majority were only positive, 3/4 were only positive in that in-process sampling. Know that we do have fruit running across the line. And unlike most processed foods, which the FDA guidance document was written for, that do have a kill step, our fresh produce don't, but they are also ready to eat. Our message to the industry was, it's important for you when you're going in sampling for Listeria species to run your equipment. The goal of the line being up and running is really to try and work some of the Listeria out of those niche points where they may be worked down into surfaces that you're not going to isolate if you just go in and sample during the right after sanitation. The positive surfaces were really our polishing brushes, the things that tend to spin in place. There are the polishing brushes, which are associated with the wax unit operation, the brushes under the fans, the dryer rollers, and the bristle rollers. The dryer rollers are like a traditional conveyor belt in that they're moving around, but really in the design of that piece of equipment, essentially the rollers were being recontaminated on the return. And it was from a few different mechanisms. It was either through buildup of wax on the lower level of that piece of equipment, or through leaf and debris buildup over time and recontaminating that surface. So we were able to give them that insight so that they could have better programs in place to essentially make sure they're getting and cleaning that piece of equipment, and work in the future to try and move towards a few of the new packing facilities have what they call drying rooms. So they've essentially taken a piece of equipment and made it a full room so they can really get in and clean and sanitize. This is a picture of a few of these surfaces so you can get up close and have a better idea. Here's our wax polishing brushes. You can see the wax buildup. This was after a cleaning and sanitizing event, so that you can see that you have essentially still a good amount of wax left in there. So it's not hard to assume, but it looks like this. If you're just looking and doing a really quick walk by, it's really down at that core of that tuft and that bristle that you're getting that buildup. So really applying a good degreaser, right? Something really alkaline is going to take care of this lipid essentially and remove it before you apply your sanitizer, was our wording there. A lot of people have focused on horsehair versus fully synthetic brushes. We did not associate, we had packing houses that were using both designs, and we didn't really see an association there with more positives in one versus the other in this study. Under the fan dryers, again, this just gives you an idea. Again, a lot of tufted bristles used here, not the core wrapped, but again, just really hard to get in and clean down at that core. And you still have a lot of debris and leaves and things along those lines that can be dropping off Listeria over time. The dividers that I spoke about are shown right here. They're hollow underneath and essentially don't lift off. So trying to change that design was something we really emphasized with the group, because once you got in and underneath them, it was a great harborage point for Listeria. Here's the dryer, and you can tell that it's a really narrow, when you talk to the sanitation crews, it was a tough piece of equipment to clean because it doesn't allow really great access. And here's the rollers that were getting recontaminated on that return. Essentially, it goes down, it has a really short return back through. So really trying to emphasize moving away from this, or giving your crews the time and it takes to actually clean and sanitize them well more frequently. So overall, what we saw was Listeria prevalence around 4.6% when we aggregated all the data together. Wax coating was that unit operation that was associated with the highest presence of Listeria species. And overall, the industry needed to do a better job of managing this unit operation to try and remedy issues that may come up. So our take-home message for the industry was that they really needed to start to try and get to a place where they could sample for Listeria species. It was really important for them to get there. Again, trying to have, if you're in the world of ATP only testing, trying to move and build your organization a little bit closer. And we really, several of the facilities during this study over the course of the 2 years did start to develop this proactive sampling for Listeria species on their food contact surfaces to try and better manage risk. So I want to say a big thank you to my lab group that was in Washington State. Although I'm a dog now, they did a wonderful job. The Washington Tree Fruit Commission funded this research. So I also really thank their support for it. And thank you.
Hey, Faith.
Yeah.
We have one quick question from the chat.
Okay. Let me look. Yeah, so, and the question is, in my experience working with the packing houses in this study, how well are they removing that residual wax from the brush rollers during sanitation? Some of them were doing extremely well, and they were giving the time necessary to their crews and going in, and I would say really a high association with, I'll stop sharing, get out of here. Really more of a proactive approach when it came to looking at visual inspection, because it's not hidden, right? It's right there in front of you. So really looking at that was key. And in the facilities that did that more visual inspection, they did not have as high an association with those polishing brushes. Which was a nice message. Others were doing a really poor job at removing that wax. And so it was really essentially messaging around like, this is not just wax, it's entrapping other microorganisms, so please get rid of it. And so your sanitizer can do its job, because it is a lipid, right? So we need to have a different cleaner even when we are trying to remove it.
We have one more question online.
Okay.
Are you seeing interest in the use of novel food-safe antimicrobials in the wax coating?
Oh, sure. Yeah, I think the apple industry is game for anything, especially since they've identified this risk, right? So they would be ultimately interested in trying to manage anything if for inclusion, if it worked well and manage the risk. What we do see is that apples, which is a really great thing, really do not support the growth of Listeria. That's a nice thing for us, right? But when it comes down to it, they still see clearly there's a risk to their industry and want to be more proactive versus less. Any other questions?
Faith, are you seeing any packing houses that aren't using wax?
Oh, sure. So organic apples rarely have wax applied to them. That's more so a ode to that there are organic compliant waxes, but traditionally we don't see wax applied as much. Otherwise, a shellac based wax is regularly used for conventional apples because it does help prevent, water loss and things along those lines, and gives them a much longer shelf life than they would otherwise have. Well, and I think as consumers, we're all pre-programmed to wanting that nice shiny apple, right? So that's how you get it at the end of the day. Well, I am really sorry again. I wasn't able to join you today, but really glad I didn't expose anyone to COVID, and really look forward to interacting with this group more. And thanks for the invitation to share some of these results, and look forward to sharing more with you all as we get started on produce safety research that for some more of our taking what we've learned essentially in Washington and applying it to other packing houses for Georgia relevant commodities, because that is definitely produce safety is my passion. And the packing house is one of these areas where we can provide so much more control when we look at fresh produce versus everything else in that chain of command when it comes to produce production. And, you can't change rain events, wild animal movement, so many other things, but we really can start to apply a lot of control when it comes down to the packing house. And we've seen historically that when things go wrong during this packing unit operation, you can really compound and multiply illnesses and everything else. So look forward to continuing to work on that as we get our program up and running here at the University of Georgia.